So in the previous video, we looked at the different shapes of the different hybrid orbitals. One thing we didn't talk about is these, as I said, these pesky unhybridized p-atomic orbitals. So what's going on with these things here? Furthermore, how does all this stuff marry up with single bonds and double bonds and triple bonds? How do they all work together? Okay, well, let's choose a nice example. Some of you might know what this molecule is here. Well, it's a UPAC name for those of you who studied secondary high school chemistry, would be ethine. It's also known as acetylene. And where is it used in day-to-day life? It's the fuel that welders use. So when they're welding steel, they get a mixture of acetylene gas and oxygen gas. They mix it together, makes a nice hot flame, and that's what they use in the blowtorch for welding. So it's a really nice example of a molecule to talk about these different sorts of hybridizations. So let's think about the hybridization here. So I've got two carbon atoms in this case, and what I'm going to do is I'm just going to draw two carbon nuclei. Now let's have a think about what sort of hybridization I'm going to have on these two carbon atoms. I said to you in the previous video, you can actually work out which one of these three hybridization schemes you have by looking at the geometry. Now, we just saw from the Lewis structure I drew for acetylene, it's an interesting molecule, it's pretty much a straight line. It's linear in geometry. Linear is always sp2. Actually, I can think of a couple of counterexamples, but they're pretty obscure. Most of the time, linear geometry is going to give you sp2 hybridization. Okay, cool. Well, let's start drawing some hybrid orbitals. So on this carbon atom, I'm going to draw one here. Notice it's kind of pointing towards the other carbon nucleus. And of course, I've got one here. Let me do the same on this carbon atom. And they're overlapping, which is really good. We like it when bonds overlap, because that's bond formation. We've formed a bond between the two carbon nuclei. Okay, what else have we got? Well, we've got the two hydrogen atoms, so let's just draw those in. I've got a hydrogen atom hanging out over here. Now for hydrogen, we just draw a little circle, and of course the circle corresponds to the 1s orbital on a hydrogen atom. We don't usually talk about hybridization on a hydrogen atom. So there we go. Now, we saw in the Lewis structure there was a triple bond here. I've only formed one bond so far. So if this thing has a triple bond, where is the other bond coming from? So this is where the unhybridized p-atomic orbitals come from. Let me get back to blue. So does everybody remember what a p-atomic orbital looks like? Yep, remember it's got that shape that looks something like this. So we notice that on a carbon atom there are still two of these p-atomic orbitals. I've drawn one of them here. There's actually another one, and it's kind of pointing out towards you guys. Now it's really hard to draw in 3 dimensions, so I am just going to draw it as a bit of a dotted line. But bear in mind that that's kind of pointing out, not along the edge of the perspex, but kind of out towards you guys and back towards me. Now we've got the same thing happening on this carbon atom over here as well. And there's one here, like so. So they're just sort of pointing in, I don't know, they're pointing up, they're pointing down, they're pointing towards me, they're pointing towards you. They don't seem to be pointing towards the other carbon atom. So these p-atomic orbitals, they're not really pointing towards that carbon atom, and vice versa. Well, that's okay. you can still form bonds using these orbitals. In fact, what happens is these two overlap with one another, but in a kind of weird sort of way. And they do it up the top here. And see how I've sort of blurred them together like that. And the same thing happens at the bottom. And this is where it gets really weird, and what some people don't understand at first, and that is that these two blue sections that I've drawn in here is one chemical bond. It looks like two different bonds, maybe, not very good bonds. You know, the electron density is not in between the two carbon nuclei, it's kind of up here and down here. Still a chemical bond. It's one chemical bond, it just has two bits to it, and it's called a pi bond. So the pink here is called a sigma bond, while the blue is what's called, put a little sigma sign there, whereas the blue is what's called a pi bond. And it's kind of pointing up and down, and there's two of these things. The other one is actually pointing towards you and back towards me. So you've really got to think in 3 dimensions when it comes to these things. So I'm going to wrap it up there, but that's an example of what these things look like and what these unhybridized p atomic orbitals are doing. They are actually doing something. They're forming pi bonds. So the overlapping hybrid orbitals are forming sigma bonds, and the overlapping unhybridized p atomic orbitals are forming pi bonds. You can see where the S and the P and the sigma and the pi come from after all, right? Okay, good luck with this topic.